Hello everyone, welcome back to my channel once again. So as we have started the lesson from the class 10th, metals and non-metals, that is a chapter number 3. So here we are going to understand how do metals and non-metals react. So let's begin. So let's understand how metals react with the other salts, other metal salts. For example, this is a metal A which is reacting with salt solution of B, salt solution of B. What will we will get? We will get salt solution of A, okay, plus metal B. So what exactly happened here? Only the displacement of the metals. So this type of reaction is called displacement reaction. So how exactly metals are reacting? So for this you have to go a little bit backward, that is in the 9th standard. Not exactly, just by your mind. Okay, why we have to go behind? Yes, to recall about the valence shells or valency shells of each and every element. We know there are 4 valence shells are there. K, L, M, N. Okay, so from these what you can remember now? Yes, it is all about the octet rule and the stability of each and every element. So here we have, by taking this example of sodium, okay, what is the atomic number of sodium? Yes, it is 11. Okay, it is 11. So what is the electronic configuration of 11? That is 281. So by keeping these electrons in electronic shells, valence shells K, L, M and N, what you can observe here, in the last orbit of sodium, okay, if you draw like this, Na first orbit, second orbit and third orbit. Okay, so by keeping all these electrons 1 2, then here 1 2 3 4 5 6 7 8, and the last one only 1. So in the last orbit you can see only one electron is there. Okay, only one electron is there. So what is the octet rule? Octet rule says that element should have in that orbitals, last orbit, it should have 8 electrons. Okay, but here only one electron is there for the sodium. So to ask 8 electrons from different elements, okay, from different elements, it is quite difficult to ask someone, right? So what exactly sodium do? It will just sacrifice this one electron and become, the electronic configuration will be like this and it will become Na plus. So we can write this as Na, which has the electronic configuration right now, this one 281. Okay, by losing one electron it will become Na plus, and the electronic configuration is like this, and this will called as sodium cation, plus by losing one electron. Okay, how many electron you lose, that many plus signs you will get. Similarly for the chlorine also, chlorine has atomic number 17 and it shows the electronic configuration 287. So in the last orbit of chlorine we have 7 electrons, right? So to follow the, or just to complete the octet rule, it need only one electron, right? So it is quite easy. So what we will what chlorine will does, chlorine, it has the electronic configuration right now 287. He is accepting the one electron, right? It is accepting the one electron. So for accepting one electrons, it will get the minus charge on it. It will get the minus charge and the electronic configuration will be like this 288. Here it is 287, but it is 288 by accepting the one electron. So what you understood, we got Na plus and Cl minus, these two ions we got. So we know that whenever the ions come in contact, they form ionic compounds. They form ionic compounds. And in these ionic compounds, what they share? They share electrons. Okay, so we can write this as Na, which has 1 electron, plus chlorine, which has, I'll show you like this, 7 electrons. Yes, so for accepting 1 electron from the sodium, it is accepting this 1 electron from the sodium and filling this gap here. So how we can write? We will write like that, Na, which got the charge, that is plus charge, and we have the chlorine with the new electron from the sodium and the remaining 7. In this way, what we got? We got here NaCl, sodium chloride.